The idea behind the SCRIMS project was to develop a system that could sit within a passenger train and monitor the condition of the conductor rail. Such a system could identify areas of high impact on the Shoegear and focus rail infrastructure maintenance. The overall goal being to reduce damage to rolling stock and prevent power loss caused by damage to the Shoegear. The SCRIMS system can automatically report locations of high impact forces, which could indicate track degradation, foreign objects or issues with the vehicle setup. The data collection could be used by Govia Thameslink Railway to inform train maintenance activities.
This project was quite unique in a lot of ways. In a factory setting, you have quite a lot of control over the environment, where you're putting sensors, the cable routing, etc. But all of that changes when you consider deploying a monitoring system on a publicly running train. Working closely with GTR, we were able to put together a system that was capable of gathering important and relevant data while being robust enough to be deployed on the underside of a train, and also meeting the safety standards of being on a passenger train.
The unique operating environment of a train in live service presented a number of key problems for us to overcome in developing the SCRIMS software. The system had to deliver sufficient data quality, be performant, be reconfigurable, and guarantee message delivery. To meet these requirements, we developed an end-to-end pipeline to access, store, process, and communicate data to our customers' cloud computing platform. The software read live inertial measurement and GPS sensor data and stored it to an edge database. A rolling novelty detection algorithm scans the incoming data and compares it against a set of user predefined rules. Results that break these rules are flagged as events and packaged up to be transmitted to the cloud computing platform. The software transmits a regular message to Azure IoT Hub indicating the train's location, speed and trajectory at any given time. When an event is flagged, a larger packet is uploaded directly to Azure Blob Storage. The software is packaged within a graphical user interface, allowing the user to really easily configure the rules, the administration, monitor the error logs, and access the dashboarding capabilities.
Early on in the project, we identified that we weren't actually going to see any real-world data until we got to the first-in-class deployment. So what we ended up doing was creating a prototype of the SCRIMS system to conduct some lab tests. We worked with the structural testing group to conduct a test using a hydraulic ram to simulate the movement of the conductor rail as the Shoegear came into contact with it. And using data from GTR, we were able to make sure that those lab tests were as close to the real world as possible.
The first-in-class trial was the first time that we had access to real data that was representative of the actual operating condition we were deploying our system to. The level of noise we observed was quite significant and wasn't something that we were able to simulate well in our lab environment. With this data, we were able to perform an analysis to determine the optimum rule set parameters that we could use for extracting event information out of the raw sensor data.
There are now 5 SCRIMS systems deployed on the rolling stock, gathering data about the track conditions across the rail network. We're continuing to work with GTR and other partners to ensure that the collected data is providing a real benefit to all of the project stakeholders.